Imagine floating in the silent darkness of space, surrounded by stars scattered across an endless cosmic ocean. It feels like space should be empty, an enormous void where planets and galaxies simply drift. But what if space isn't empty at all? What if the universe itself is more like a vast, invisible fabric, one that bends, stretches, and warps whenever something with mass appears? Right now, as you sit watching this video, the Earth beneath your feet is actually bending space around it. The Sun is warping the geometry of the entire solar system. Even distant galaxies are twisting space-time across unimaginable distances. And here's the astonishing part. This curvature of space is what we experience as gravity. But why does mass have this strange power over the universe? Why should matter reshape the geometry of reality itself? To answer that question, we're going to take a journey from the smallest particles to entire galaxies, and all the way back to the birth of the cosmos. By the end of this video, you'll see gravity, space, and the universe itself in a completely different way. Out in the vast theater of the universe, something strange is happening, something almost impossible to imagine. Massive objects like stars, planets, and black holes don't just sit quietly in space. Their very presence seems to bend the fabric of reality itself, subtly reshaping the cosmic stage around them. Picture placing a heavy bowling ball onto a stretched rubber sheet. The surface dips and curves beneath the weight, creating a gentle valley in the material. Now imagine that sheet isn't rubber at all, but space itself, an invisible structure extending across the entire universe. This idea suggests something astonishing. Space isn't empty in the way we once imagined. Instead, it behaves more like a flexible fabric, capable of stretching, bending, and warping under the influence of mass. Wherever matter gathers, the geometry of the universe quietly rearranges itself. But that raises a profound mystery. Why should matter have this strange authority over space? Why does a star's mass twist the paths of planets and light, almost like an invisible sculptor shaping the cosmic landscape? Somewhere within this hidden relationship lies one of the deepest secrets of the universe. And as astronomers peer into the sky, they've begun to notice something remarkable. Evidence that this bending of space isn't just a theory. It's happening everywhere we look. Once scientists began searching for signs that space could bend, the universe started revealing clues in the most spectacular ways. Light from distant galaxies sometimes arrives at Earth along strange, curved paths, as if it had traveled through a warped cosmic landscape rather than straight through empty space. Imagine rolling a marble across a perfectly flat table. It moves in a straight line without hesitation. But if the table suddenly dips in the middle, the marble curves toward the depression, following the shape of the surface beneath it. Light behaves in a surprisingly similar way across the universe. When it passes near extremely massive objects, like galaxies or clusters of galaxies, its path bends, gently curving through the distorted geometry of space. Astronomers have captured breathtaking images of this phenomenon. Distant galaxies appear stretched into glowing arcs or even duplicated into multiple images, all because their light traveled through regions where space-time had been warped by enormous concentrations of mass. In other places, stars orbit invisible companions that cannot be seen directly, yet their motion reveals the presence of something extraordinarily heavy, often a black hole quietly bending space-time nearby. These cosmic motions hint at a deeper structure hidden beneath the universe's surface. And as powerful as these effects appear across galaxies and black holes, they raise an intriguing question. If massive objects can bend space on such enormous scales, what happens when we zoom all the way down to the smallest building blocks of matter itself? To understand why mass bends space, the journey doesn't stop with stars or galaxies. Instead, it dives inward, past planets, past atoms, and into the tiny world of particles where the fundamental ingredients of reality quietly operate. Inside every atom, particles carry both mass and energy, the two currencies of the physical universe. Even though these particles are unimaginably small, they still influence the geometry of space-time around them, ever so slightly. It's almost like placing a single grain of sand on that stretched rubber sheet. The dip it creates is tiny, so small it's nearly impossible to notice. Yet the surface still responds, adjusting its shape to the presence of even the smallest weight. In the same way, every particle contributes its own minuscule wrinkle to space-time. Individually, these distortions are almost invisible, but when countless particles gather together, As they do in planets, stars, and galaxies, their combined influence becomes powerful. So the universe builds its grand structures from countless microscopic contributions. Tiny distortions from atoms accumulate, layer upon layer, until entire regions of space become curved landscapes guiding the motion of celestial bodies. And when enough matter gathers in one place, those tiny wrinkles grow into something far more dramatic. That's when the curvature of space-time begins shaping the paths of moons, satellites, and planets themselves. Now the story expands from the microscopic world to something far more familiar, our own cosmic neighborhood. Planets, moons, and satellites move through space in graceful, predictable paths, almost like dancers following invisible tracks around their partners. Take Earth, for example. Our planet carries an enormous amount of mass, and that mass subtly curves the space-time surrounding it. The effect isn't dramatic enough to see with the naked eye, but its influence quietly guides everything moving nearby. Imagine a marble rolling across a curved bowl. Instead of traveling straight, it naturally follows the shape of the surface beneath it, spiraling or circling depending on how it moves. The marble isn't being pulled sideways, it's simply following the curved path available to it. The moon behaves in a remarkably similar way. It travels through the curved space-time created by Earth, tracing a stable orbit that has continued for billions of years. Artificial satellites launched by humans follow the very same geometric pathways. Even astronauts aboard the International Space Station are part of this cosmic dance. They appear weightless, not because gravity disappears, but because they are continuously moving along the curved structure of space-time around Earth. And if the curvature created by a single planet can guide moons and spacecraft so precisely, it raises an exciting thought. What happens when humanity starts relying on this subtle bending of space-time to navigate across the surface of our own world? Surprisingly, the bending of space-time isn't just a distant cosmic phenomenon. It quietly influences technology used by millions of people every single day, often without anyone realizing that the physics of the universe is working behind the scenes. Consider the Global Positioning System, better known as GPS. Satellites orbit high above Earth, constantly sending precise timing signals that allow phones, cars, and airplanes to determine their exact position on the planet. At first glance, it might seem like simple geometry and radio signals doing the job. But hidden within the system is a subtle complication. Time itself flows slightly differently for satellites than it does on Earth's surface. Because these satellites orbit farther from Earth's mass, they experience a slightly weaker curvature of space-time. As a result, their clocks tick just a tiny bit faster than clocks on the ground. The difference is incredibly small, only microseconds per day, but over time, it would create navigation errors of several kilometers if ignored. Engineers must correct for these relativistic effects to keep GPS accurate. So every time someone checks directions on their phone, they are unknowingly relying on Einstein's description of curved spacetime. And this practical success hints at something profound, a deeper theory that explains why mass reshapes the geometry of the universe in the first place. To truly understand why mass bends space, the journey leads to one of the most revolutionary ideas in the history of science. In the early 20th century, a young physicist named Albert Einstein proposed something astonishing about the nature of gravity. For centuries, gravity had been imagined as an invisible force pulling objects toward each other, much like a rope connecting planets and stars. But Einstein suggested something far more surprising. Gravity might not be a force at all. Instead, he introduced the concept of space-time, a four-dimensional fabric combining space and time into a single structure. According to his theory of general relativity, mass and energy reshape this fabric, curving it the way weight bends a stretched surface. When objects move through this curved geometry, they simply follow the natural paths available within it. Just like a marble rolling along the contours of a curved bowl, planets move along the curves created by massive bodies. From this perspective, gravity isn't pulling objects together in the traditional sense. Instead, matter tells space-time how to curve, and curved space-time tells matter how to move. This elegant relationship explains why planets orbit stars, why light bends near galaxies, and why time itself slows in strong gravitational fields. Yet this raises another fascinating question. If massive objects can shape space-time so profoundly, how did this influence the formation of entire planetary systems? Long before Earth existed, before oceans or continents or life itself, Our region of the galaxy was filled with a vast drifting cloud of gas and dust. This enormous cloud floated quietly through space until gravity slowly began drawing its material inward. As more and more matter gathered together, the growing mass began curving the surrounding space-time more strongly. Just like water spiraling into a whirlpool, the gas and dust started moving along the curved paths created by the forming star at the center. Over time, the collapsing cloud flattened into a rotating disk surrounding the newborn sun. Within this swirling structure, particles collided, stuck together, and gradually built larger and larger bodies. The process was a bit like watching tiny snowflakes accumulate into a snowball. Small grains became pebbles, pebbles became planetesimals, and eventually entire planets emerged from the spinning disk of material. All the while, the sun's growing mass shaped the space-time around it, guiding the motion of the forming planets along curved pathways that would later become stable orbits. And from this ancient cosmic construction site, a remarkable planetary system took shape. Yet one particular planet would end up following a path especially important for life, because its orbit within the sun's curved space-time turned out to be just right. Among the planets that formed in the swirling disk around the sun, one world found itself traveling along a remarkably stable path. Earth moves through the curved space-time created by the sun, tracing an orbit that has remained steady for billions of years. This motion might look like a simple circle drawn in space, but in reality it's the natural path through a gently curved cosmic landscape. Much like a marble circling the inside of a bowl, Earth follows the geometry shaped by the sun's immense mass. Because of this stable journey, our planet receives a consistent flow of sunlight. Day after day, year after year, the rhythm of Earth's orbit helps regulate temperatures, seasons, and the delicate balance that allows life to thrive. The changing seasons themselves are part of this cosmic dance. As Earth moves along its curved path and tilts slightly on its axis, different parts of the planet receive varying amounts of sunlight throughout the year. From the growth of forests to the migration of animals, life on Earth is deeply connected to this gravitational choreography. Even the length of our year, 365 days, is defined by our planet's path through space-time around the sun. Yet while Earth's orbit feels vast from our perspective, it's only a tiny ripple within a much larger structure, because the same curvature shaping our solar system also operates on far greater scales, across entire galaxies filled with billions of stars. Now the scale expands dramatically. Instead of a single star shaping the motion of nearby planets, entire galaxies influence the geometry of space-time across regions spanning hundreds of thousands of light-years. A galaxy like the Milky Way contains hundreds of billions of stars, vast clouds of gas, and enormous amounts of unseen mass. Together, all this matter bends space-time on a scale almost impossible to visualize. Stars orbit the galactic center, much like planets orbit the sun. But here, the dance is far larger and slower, each star taking hundreds of millions of years to complete a single circuit through the galaxy. Imagine a massive cosmic carousel stretching across space. Every star moves along curved paths shaped by the combined mass of the entire galaxy, not just by a single object. Astronomers studying these motions discovered something puzzling. The outer stars move far faster than expected, as if additional unseen mass is helping curve space-time across the galaxy. This mysterious influence points toward something called dark matter, an invisible form of mass that may dominate the gravitational structure of galaxies. And if galaxies themselves bend space-time on such enormous scales, it raises an even bigger question. What happens when we zoom out beyond galaxies, back to the earliest moments of the universe itself? To understand how space-time curvature shaped the universe, the journey must travel all the way back to the beginning. Roughly 13.8 billion years ago, the universe burst into existence in an event known as the Big Bang. In those earliest moments, the universe was unimaginably hot and dense. Matter and energy filled every region of space, and the geometry of space-time itself was rapidly evolving as the cosmos expanded. Think of it like ripples spreading across the surface of water after a stone is dropped. As the universe expanded, tiny variations in the distribution of matter created slight differences in how space-time curved from place to place. These subtle differences acted like seeds for cosmic structure. Regions with slightly more matter curved space-time a little more strongly, attracting additional material over millions of years. Gradually, these growing clumps became the first stars, the first galaxies, and eventually the immense cosmic web stretching across the observable universe. In this way, the large-scale architecture of the cosmos was shaped by the interplay between matter and the curvature of space-time from the very beginning. Yet even after uncovering this incredible story, from particles to planets to galaxies, one final thought remains. If mass can bend space itself, what does that reveal about the deeper nature of the universe we inhabit? When humanity first looked up at the night sky, the universe seemed like a silent stage where stars and planets simply moved through empty space. But modern discoveries reveal something far more profound. The stage itself is alive, constantly shaped by the matter within it. Mass does not merely exist within space, it reshapes the structure of reality. Every star, every planet, every grain of cosmic dust gently bends the geometry of space-time, subtly influencing how the universe unfolds. It's almost as if the cosmos is woven from an invisible fabric, and every object leaves its imprint upon it. Like footprints in fresh snow, matter presses into space-time, creating pathways that guide the motion of everything around it. From the orbit of the moon to the motion of galaxies across billions of light-years, the universe follows patterns written into the curvature of space-time itself. The same invisible architecture connects the smallest particles to the largest cosmic structures. And in learning to read these patterns, through ideas like general relativity, humanity has taken a remarkable step toward understanding the deeper design of the cosmos. Because the more we explore this bending of space and time, the more we realize something extraordinary. The universe is not just a place where events happen. It is a dynamic structure, constantly shaped by the matter that fills it.